In this video, I will show that addition of just one dihedral plane to the point group D3 generates the entire D3d point group. This is the diagram for D3 point group. It has one principal C3 axis denoted by this triangle, and this is the equatorial plane, this is the horizontal XY plane denoted by this dotted circle. The Z axis is perpendicular to this plane, and the C3 axis coincides with the Z axis. And there are three other twofold axes perpendicular to the principal axis. This C21, C22 and C23. These are the elements of the point group D3. We have the symmetry operators, identity, and C3, C3 square, C21, C22, C23 for the D3 point group. These are the symmetry operators of D3 point group. Let us now see what happens if we add just one sigma D operator, one reflection operator on a dihedral plane. Suppose we are adding a dihedral plane. Dihedral plane bisects the angle between adjacent C2 axis. So this is one sigma D plane. Let us examine what happens after addition of this plane. To do that, we have to multiply this added new operator with all the previous operators. If we multiply sigma D with E and see what happens when a general point P plus is subjected to this operation. P plus means a point, general point, that is a point which does not lie on any symmetry element and it is above the plane of the paper. When projected on this XY plane, the point gives a projection like this, somewhere here. This is our starting point. Actual point is above the plane of the paper. It is projected on to the XY plane, and that projection point is denoted by this plus symbol. We will see what happens when sigma DE is applied to P plus. Then again we will see what happens when sigma D C3 is applied to P plus, and so on. What happens here? This means sigma D on P plus. This is equal to what? P plus, when reflected on sigma D, will come somewhere here. The point was above the plane of the paper. After reflection, because the sigma D plane is vertical plane, it contains the C3 axis, therefore the plane above the plane of the paper will remain above the plane of the paper. Its projection will come here. Let us call it Q. Then sigma D P plus is Q plus. Q plus. This is a new point, and therefore this is also a new operation in the newly generated point group. Then we will multiply sigma D with C3, and see its effect on P plus. Sigma D on C3P plus. C3P plus means the point is rotated through an angle of 120 about the principal axis. C3P plus comes somewhere here. Here, this point after C3 rotation comes here. Let us call it R. Then this part is R plus. And what happens on reflection, sigma d plane is this. If r plus is reflected on this plane, we will come to a position like this. From here, by reflection, we'll arrive at here. Let us call it S. Then this is S plus. And how can we come from P plus to S plus directly? We can do so if we have another plane of symmetry here, reflection plane, in this manner. If we have another reflection plane like this, then P plus by reflection will come to S plus. So S plus may be written as sigma d. This is also a dihedral plane because it bisects the angle between these two C2 axes. We call it sigma d primed. So sigma d primed on P plus. This result is equal to sigma d primed on. Therefore, sigma d C3 gives a new symmetry operator, sigma d primed. Sigma d primed, and a new plane of symmetry here in this stereographic projection diagram. Then we have to multiply sigma d with C3 square. Sigma d with C3 square, and see its effect on P plus. C3 square on P plus, C3 square means 1 C3, then again C3. P plus by a C3 square rotation will come here. Let us call it T. Then our result is sigma d T plus. And when this T plus is reflected on this sigma d plane, sigma d plane is like this. On reflection, we will arrive at a position like this. Let us call it U. Then this is U plus. And how can we come from P plus to U plus directly? Again, a reflection plane like this is needed to come from P plus to U plus. We need another plane of symmetry like this. This is another dihedral plane. Call it sigma d double primed. Then this U plus may be written as sigma d double primed on P plus. Therefore, we generate another operation, sigma d double primed, and another plane of symmetry. Then we have to multiply sigma d with C21. Sigma d with C21. We are multiplying the added sigma d operator. This is the added sigma d plane. The added sigma d operator, we are multiplying the sigma d operator with all the previous operators of D3. Sigma d multiplied with C21 and applied on P plus will give you sigma d, then P plus being subjected to this rotation, a twofold rotation about this axis. From above the plane, we'll go to a position below the plane. Therefore, our projection will be like this. So we get this point. Let us call it UV. This part is V hollow. And when this V hollow is reflected on this sigma d plane, we come to a position like this. Let us call it W. So here the result is W hollow. And how do we come from P plus to W hollow directly? By a rotation like this and then reflection on the XY plane. A rotation, this rotation is actually a rotation through an angle of 300 degrees. This angle is 60. This entire angle is 120, therefore this angle is 60. So in this direction the angle is 300 degrees. That is a C6 5 times rotation followed by a reflection on a perpendicular plane on P plus will give us W hollow. And this is a S6 operation, S6 5 operation on P plus. Therefore, we get a new operation S6 5 operation, an improper rotation. Therefore, here there is an improper axis, 6-fold axis, and that axis is collinear with the 3-fold principal axis because this rotation is about the same C3 axis. So here the existence of S6 will be denoted by a hexagon like this. Existence of the improper 6-fold axis will be denoted by in this manner. The inscribed triangle will be darkened. This means that the S6 axis is collinear with the principal C3 axis. Then we have to multiply sigma d with C2 2 and see its effect on P plus. What will happen? Sigma d P plus on C2 2 rotation. C2 2 axis is this. If we rotate P plus about this axis C2 2 through 180 degrees, that is, we have to rotate in this way. From above we will go to a position below the point if we rotate about this axis. So its image after C2 2 operation will be like this. Here, let us give it a name, say A. Then this part is A hollow, and when this point is reflected on the sigma d plane, we will arrive at a position like this. Call it B. So our result is B hollow. And then how can we come from P plus to B hollow? By a 60 degree rotation and then reflection on a perpendicular plane. So this is actually a 6 operation carried out on P plus. Therefore we have generated the S6 operation. S6 operation. Then we have to multiply sigma d with C2 3 and see the result on P plus. We will find sigma d P plus upon C2 3 rotation. C2 3 line is this. C2 3 line is this. P plus on being rotated about this C2 3 line through an angle of 180, P plus will come here. P plus will come to this position. Let us call it say B, C, D, E, F. We omit C, D and E. Let us call it F. Then this result is F hollow, and when F hollow is reflected on this sigma d plane, we come here. Let us call it H. Then our result is H hollow. And now from P plus to H hollow we can come by an inversion through this center. This may be written as inversion on P plus, or we may also consider it as S6 three times. S6 one time will bring you here, another time will bring you here, and then the third time will bring you here. So this may also be considered as S6 three times. That is, this is actually S2. And we know that S2 and I are equivalent. So we have generated another symmetry operator, inversion. And that center of inversion is at this position. So in all there are 12 symmetry operators. We are now to see whether this set is closed. Therefore, we have to multiply the newly generated operators, two of the newly generated operators. Suppose we multiply sigma d primed. This is a newly generated operator with sigma d double primed. These have been newly. Sigma d was initially taken, and the sigma d prime, sigma d double prime, etc. have been generated. So let us multiply these two and see whether any further operation is generated. We apply this product on P plus. Sigma d primed on this part, P plus upon sigma d double primed reflection will give you U plus. If this is taken as the plane of symmetry, then P plus will bring you to U plus. Therefore, this part is U plus, and then U plus on being reflected on this plane, sigma d primed plane, will bring you to R plus. So no new point is generated. No new point is generated. This R plus is actually what? This R plus is C3P plus. C3P plus. This is an already known operation. Therefore, no new symmetry operation is generated by the product of the newly generated symmetry operators. We can carry out all possible binary products, and we will find that this whole is a closed set of symmetry operators, and therefore these will form a new point group, and that is in fact the D3d point group. This is the stereogram for a D3d point group. It has altogether how many operations? 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 operations in all. So the order of the group D3d has order equal to 12. Order means the number of symmetry operators in the group. And we see that in D3d, I is present. I is present in D3d. We earlier observed that D2d does not contain I, but here we see that D3d contains I. So in this way, by using stereographic projection, we can generate new and new point groups in this manner. This is a very useful technique. I will show you application of this technique to some other point groups, and then finally I will come to some conclusion. This technique will make you will enable you to classify these symmetry operators. You will find that identity is conjugate to itself. C3 and C3 square, this is a conjugate pair. By similarity transformation using this technique, you can find that C3 is conjugate to C3 square. Similarly, these three twofold rotation operators are also conjugate to one another. In this way, you will find that there are 6 conjugate classes. 6 conjugate classes. This is very easy to determine using this technique. So, with this I finish today. Let me thank you for watching the video.